Okay, this is a video to help you understand how to solve absolute value inequalities. Hopefully in the past you've learned how to solve absolute value equations and also remember how to work with inequalities, but combining those two ideas can be somewhat tricky sometimes. There are essentially two types of absolute value inequalities. There are what I like to call between inequalities, where the distance from zero, remember that's what an absolute value is, the distance from zero is less than a certain number, c, or some distance, or that distance from zero is less than or equal to that. And a graph, typical graph for that will look either like this, where the two open circles are connected with a straight line, or they could be two solid circles, depending on if there's an or equal sign there. The distance must be greater than one number and less than another number when you look at the two separate ideas once they're solved. In a beyond equation, that, on the other hand, is an or equation. I'm going to go ahead and mark that. Remember that this is going to be an or, and technically this comes out as an and. In a beyond equation, you're saying that the distance is greater than some certain number. So from the middle, the distance outward is greater than. It could be more than to the left or more than to the right, but from that middle to those two dots or farther than. So you're going to go out beyond those two things. And again, could be greater than one number or less than the other number. So let's take a look at a couple of equations and figure out how to rank them and how to solve them. First thing you want to decide is it between or a beyond equation? Do we want to work with an and, or if it's beyond, working with or? And that'll give us an idea what our graph should look like when we're done. So notice that in both of our inequalities, our absolute values are isolated right now, which is the perfect time to split them and decide and versus or. The distance being greater than tells me that I want to go beyond. I want some equation where when I finish my final answers, I'm going to go out from the middle a certain distance or beyond that. And since there's an or equal to, I can actually fill in my graph to show that I'm going to be two solid dots, and again I'm going to be beyond. So now let's go ahead and split and solve. Since we know it's beyond, I'm going to put or in between. I know that the left side can be 11 minus 2x is greater than or equal to 13. On the right side though, remember what's inside the absolute value could have come up negative. So negative parentheses 11 minus 2x could be greater than or equal to 13. So now we can solve. Negative 2x subtract our 11 is greater than or equal to 2. And if I divide by a negative 2, remember to flip that sign, x could be less than or equal to negative 1. Or, if we move that negative right away, remember you've technically divided by a negative, so we're going to flip the sign right away to become a negative 13. I'm going to subtract my 11 again, and so that becomes less than or equal to negative 24, and x could be greater than or equal to, because again I'm going to divide by a negative, 12. So x is greater than or equal to negative 12, or at the exact same time, x could have been less than or equal to negative 1. So if I put my negative 1 here and my 12 there, you'll notice that our graph corresponds to our two statements, and everything seems to line up just right. Taking a look at our second example, your absolute value is less than, which means it's going to be an and equation. So immediately I'm going to write and. If you really want to, you can also go draw your graph. Again, between your two numbers. No equal sign means there's going to be a couple of open circles, and my graph should come out in between. So x plus 8 is less than 5. Or negative x plus 8 could also have been less than 5. Again, I'm going to immediately flip that negative to the other side, remembering that when I move that negative, I also need to flip the sign. And that's the most common mistake people make. Either they put the negative on the right side immediately and don't flip the sign, or when they move that negative, they forget to flip the sign. But either way, you would have been wrong. If you subtract 8, keeping x greater than, this becomes negative 13. And at the exact same time, x, if I subtract 8 on this side, is less than negative 3. So you'll notice negative 13 is the smaller of the two numbers, negative 3 the greater, but x is less than, so below that point, negative 3, but greater than to the right of negative 13. And again, the nice part is you can rewrite these equations. If x is greater than negative 13, but at the same time less than negative 3, you can write that as a compound inequality. And notice that our variable, our line, falls in between those two numbers. Now, in the real world, where could we possibly see something that complex? Well, think of anything that you produce. Bowling pins are mass-produced, just like any sporting equipment. They're not all going to be perfectly the same, but you would want your bowling pins to be essentially the same weight to be legal bowling pins at all bowling centers all around the world. So, bowling pins essentially are supposed to be somewhere between 50 and 58 ounces in weight. Well, if we think about it, that means that if you set up an absolute value inequality, in order to be a legal weight of a bowling pin, the difference between your bowling pin and the ideal bowling pin needs to be less than or equal to, and actually no or equal to if they're going to be in between. It's not saying we're going to include those weights. We need to be greater than 50 or less than 58. Well, they're going to be less than some ideal difference. Well, if we think about it, halfway between 50 and 58 is 54. So if I take any bowling pin and subtract the ideal, that's what I would call that, ideal weight of 54 ounces, the difference between those two shouldn't be more than 4 ounces either way. Well, any weight minus 54, well, if I take 50 minus 54, that's a negative 4, but the absolute value of that would be a positive 4. Well, is 4 less than 4? No. But remember, we also said that it needs to be between, so it can't actually be 50, and the fact that that came up not working too well is great. The 4 on the right side is actually what we call the tolerance. We're going to aim for 54 ounces, but we're going to tolerate 4 ounces one way or the other. So that's a great way to set up an absolute value inequality. Your weight minus the ideal weight. The absolute value of that, we don't mind if we're high or low, because the absolute value is going to give us a positive number either way, needs to be less than some given tolerance of weight. The last page I have for you is just a practice for you. So if you want to take a few seconds, feel free to pause the video, try solving the whole problem, and see if you come up with the correct looking graph and final statement for a between or beyond absolute value inequality. Good luck, and we'll see you again in a little bit. All right, the answer is provided for you here. Again, a couple of quick notes. Remember that when you split the two equations, it's a great idea to keep your negative on the left side until, if you want to, you can either distribute it, like I did here, or you can divide it to the other side, at which time don't forget to flip your sign. Since I distributed, I didn't need to do that until later, but dividing by a negative 1/4 down here meant multiplying by a negative 4. Thus, when that became a negative 112, I had to flip my sign. X is now greater than negative 112. And you'll see that our graph came out as a between equation, which means I used the word and the whole time. And you could also write it as a compound inequality. Good luck on solving your absolute value inequalities, and have a great day.